Hi, and welcome to this video. So today we're going to be discussing the following problem. So here we have black and white rooks are placed on an 8x8 board, subject to the following conditions. So any black rook must be the only rook in its row, while any white rook must be the only rook in its column while placing these rooks. And so the question is to find with proof the maximal number of rooks that can appear in find with proof the maximum number of rooks that can appear in this board subject to those conditions. And so, yes, pause the video if you like. But yeah, once you're done, you can unpause and I'll keep going on with the solution. But yeah, it's a fun problem. If you'd like to pause, by all means, I would encourage it. So the idea is, because any black rook will be the only rook in its row, each row can contain at most one black rook. And so since there are 8 rows, that means that you could have at most 8 black rooks. It means you could have at most 8 black rooks. And you can have, and because each white rook will be the only rook in its column, and you have 8 columns, you can have at most 8 white rooks, right? And so now we're going to split. And so now suppose that you had 8 black rooks in your exactly 8 black rooks, right? Which is the most number of black rooks possible, right? That would basically mean, because you could only have at most one black rook in each row, that would mean that each row would contain exactly one black rook. But then you would basically have that once each row contains exactly one black rook, you could not add any other rook to you could not add any rook to any of the rows, because each black rook must be the only rook in its row. So since each row will contain a black rook, that black rook will be the only rook in its row. And so since you can't add a rook to any of the rows, you can't add any more rooks to the entire configuration. So if you had 8 black rooks, you could have at most 8 rooks total in your configuration, right? Because you can't add any more rooks. And if you had 8 white rooks, you could the same thing will happen. Each white rook will be the only rook in its column. Or I'm sorry, each column would have to contain exactly one right rook, and then you couldn't place any other rooks in each of the columns. So you'd have at most 8 rooks total. If instead you had exactly 8 white rooks, right? And so if you have at least one of if you have either of 8 black rooks or 8 white rooks, right? If you have 8 rooks of some color, right? Then you know that you can place at most 8 rooks total in the grid. And now suppose that you didn't have 8 rooks of one color, right? Then you'd have at most 7 rooks of each color. So you'd have at most 7 black rooks and at most 7 white rooks, right? And in this case, you could place at most 14 total rooks. So therefore, so it follows that if you placed 8 rooks of one color, right? So you could have at most 8 rooks of any particular color, right? If there are 8 rooks of some color, you could have at most 8 rooks total in your table. And if there are not 8 rooks of some color, you could have at most 7 rooks of each color, which means that you'd have at most 14 total rooks you could place. So in either case, right, if you're placing the black and white rooks subject to the conditions in the problem, it follows that you could place at most 14 total rooks in your grid. Now, to show that this that 14 is actually the maximum, right? Because we just showed that 14 was an upper bound. If we don't show it's attainable, maybe there is no configuration that has 14, right? And so maybe the max is like 12 or 13 or something, right? And 14 is just an upper bound, right? But we can actually show that 14 is actually attainable by this configuration that I drew here, where we have, in this configuration, has exactly 7 black rooks and 7 white rooks. And each black rook will be the only rook in its row, while any white rook will be the only rook in its column that's satisfied. So this is a configuration that proves that 14 is possible. So we've shown that 14 is possible in terms of having 14 rooks, and we've shown that you can't do better than it. Therefore, 14 is the max number of rooks. 14 is the max number of rooks that you can place. And so that is the answer with proof. And so yes, I hope you enjoyed the problem, and I will be seeing you next time.